That's an a minus b times a plus b. That multiplies out to an a's, oh, well, okay, green's not working. I meant to say, multiply these two out, it gives me an a squared minus b squared. So Steve, check, watch. Okay, do you agree with that? Then check this out. Isn't this true?
True.
Which means,
You just,
so I get to replace this with this garbage. That's all I did. Nothing more.
theory rearranged to begin with.
That's all I did. So, are you guys okay with this? I only have one yes.
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 Good, good, good. So what about this? This is what I'm getting at. The author might ask it something like this.
No, that'd be 3 sine.
Would that be sine of 3 times x, or sine of 3? Are you trying to put like parentheses around the 3 and the x, or is it just sine?
You
of
know what?
3?
I'm sorry. It's
Yeah.
meant. It's meant as parentheses around the 3. It's good.
Okay.
It's meant to be. Well, what's the limit of sine of x over x? Is x equals 0? Okay, agree answer this question. What's the sign of question mark over question mark as question mark goes to 0?
1.
I agree. So let's do not rewrite this as the limit as x goes to 0. And the ratio of the sign of question mark over question mark. Ah, shoot, I can't. That's not legal, is it? Let me pull out a factor of 1/5.
Yeah, it's still
Oh shoot, I still made a mistake. I put a 3 downstairs. It's not legal, is it? So I'll compensate by putting it upstairs. Now, I think this amounts to 3/5.
Trick to stop the wind tunnel.
I know, that's why you see these things removed in some of the other rooms.
They're like jumping up and down. It's like there's a party, right?
That's not going nowhere.
No, that's not an escape hatch to get out of class tonight. Oh, I'm so sorry.
It's kind of interesting, like scientific experiment.
So, do you guys agree?
Uh-oh.
No.
Why not? Be honest, I'm serious.
If x approaches 0,
Doesn't 3x go to 0 as well?
what?
Doesn't 3x go to 0 as well if x goes to 0?
Wait, what? Repeat.
Nabil, I'm sorry. Am I not enunciating? I mean, if x goes to 0, doesn't 3x go to 0 as well?
Yeah.
Okay, good. I'm happy. Are you happy? Here's why. Here's why. Watch. Different color pens. Oh, I got some green. Awesome. Watch. I pulled it out. But I'm the one who said, oh, let's throw a 3 in downstairs. That's not legal. I can't just divide by 3. I better compensate by multiplying by 3 as well. I think in red, I just multiplied by a funky little form of 1. Everybody? Seriously.
Yeah.
Sebastian?
So why is it 3x as it approaches 0?
Why not? I mean, if I know that the limit of sign of garbage over the same garbage as garbage goes to 0 is equal to 1, then I was just trying to rewrite that this thing right here is nothing more than this thing and this thing. And it's perfectly legal because, you know, as x goes to 0, 3x goes to 0 as well. Just more rapidly.
Assume that if we ever have that thing, it's just that number up there over the other one.
Yes, and I hope you believe that because I proved it last time in class with this case.
have to like do those steps, we can just say
No.
like 305.
If you insist. But if you made a mistake, I want to see the work, so I can give you partial credit.
So then it's 3/5 because the limit as 3x goes to 0 of sine 3x of 3x is 1, right?
Perfectly put, perfectly put. I agree. I heard that.
G squared. E of x.
Okay, you guys, I haven't done this. Can I not tonight? It would be another long geometric argument like I had last time. And if I were to do this, you get negative sine of x. But if I could do some hand waving, I promise you guys, just give me one more night, and I'll be able to prove to you that this is true without a long geometric argument. I promise. Just buy this just for one night. This is a math class. I need to prove anything I'm saying. I'm just saying it'll be easier for me to prove without going through another 15-minute geometric argument like I did last time, if I could just wait one night. Yeah, just one more night, just so I get to change. And if I were to differentiate with respect to x, the tangent of x is okay, I don't know. Take a break. You guys ready?
Let's do this.
No, let's not.
Oh.
Another huge geometric argument. Instead, why don't we just cheat? I think without doing any calculus. I think what I'm differentiating is a ratio of let me just use a quotient rule. I get what's downstairs times through upstairs. Minus what's upstairs times through what's downstairs. Negative sine of x. All over what's downstairs twice. But that's just simply
1
That's just 1 over cosine squared.
cosine
okay,
squared.
stop. I'm not making mistakes. But like I said before the break, Your first Pythagorean identity says sine squared of x plus cosine squared of x equals 1. So that was your first intimate relationship between the sine and cosine functions, and I gave you more intimate relationships between sine and cosines in terms of derivatives. But since the second Pythagorean identity says that tangent squared of x plus 1 equals secant squared of secant squared of x, maybe I should rewrite the derivative of the tangent function in terms of sines and in terms of secants and or tangents. I think I can. Because I think 1 over cosine squared of x is nothing more than,
Secant squared of x?
isn't that nice? So I think from now on, you should know. The derivative of tangent of x is just secant squared of x. If I were to differentiate with respect to x, the cotangent of x, jeepers, you guys, same idea, isn't it? I'm just simply going to do this. Think of the cotangent of x, no calculus, as the ratio of
Cosine of x.
to the,
Sine of x.
but that using the quotient rule gives me what's downstairs of x times the root of upstairs,
Negative sine of x.
minus what's upstairs, times the root of downstairs.
Cosine.
All of what's downstairs twice. Or shall I say -1, thank you, over sine squared of x? But that's -1.
Negative cosecant squared
Cosecant
x.
squared of x. Huge. A relationship between cosecants and cotangents with your third Pythagorean identity is that 1 plus cotangent squared of x is cosecant squared of x, but now the derivative of the cotangent of x is negative cosecant squared of x, another intimate relationship. Nabil, do you have a question? I'm sorry.
It wasn't on this, so if you have any more to say on that.
Nope, I'm done.
Oh, okay. Sorry to sort of cut you off. But,
That's quite all right.
I was just wondering, is the derivative of e to the x just a special case of the one right below it? It's right behind
Yes. As a matter of fact, Nabil, if you erase this, you're fine, because watch. If a has to be e, put e here and put an e here. But the natural log of e is,
it. Is one.
and
Okay.
therefore it's the same thing. I think this is just a special case scenario of this.
Why is it important for us to remember that independently? I mean, is it just because it's like a nifty little thing?
So
Or?
often. It's because it's a
Oh,
method
it's
for
'cause it's
So
so
can I take the next 3 weeks without nonstop talking? I mean, it's that big of a deal. Nabil, a couple things, real quick. I'm being silly. This is the only non-trivial function that remains unchanged through the differentiation process. That's huge. That's huge. Look at the graph of this beast. X-axis, y-axis. It doesn't look like this. And if I had a point labeled a comma b, it's on the graph. But what this really says up here is that if you look at the slope of the tangent line for the graph, then the slope of the tangent line is nothing more than the y-coordinate. That's huge. That's for any point a comma b on the graph of the natural exponential function. No other non-trivial function in mathematics has that quality. There's a trivial one, namely y equals 0, but no non-trivial function.
what's the definition of trivial?
Simple, obvious.
Okay.
If I had you and somebody else, excuse me, stand apart from each other, and hold a rope or a chain, and let it naturally sag, it looks like that curve's a parabola. It is by far not a parabola. As a matter of fact, that curve right there is what we call a catenary curve that can be mathematically modeled by something like this.
What's beta and whatever is that?
Some constants, depending on how far the people are standing apart.
Does it also depend on the weight and stuff of the?
No. Whoa, what a good question. You know what? If I'm an engineer and I build a suspension bridge, and I evenly distribute a weight along a curve, like a cable with a road bed below, that's going to change the curvature of that curve and transform it into an algebraic equation of this form. That's huge. You have never, I don't think anyone in this room has ever seen a relationship between a transcendental function and an algebraic function, and there's the first relationship you've seen, I assume. That's really cool stuff. That's sophisticated. That requires a lot of advanced mathematics to prove. Nabil, am I answering your question? I'm sorry, I got lost.
Yeah, you answered it.
All right.
Thank you.
Oh no, I'm not done. I haven't differentiated the cosecant or secant functions. Well, you guys, let's do it. It is, but let me show you why. Let me show you why. Because I think the differentiate to secant of x is nothing more than the differentiate in respect to x 1 over the cosine of x. Now the quotient rule says I get what's downstairs as is times root of upstairs minus what's upstairs as is times root of downstairs. All of what's downstairs twice. Or shall I say, I get the sine of x over the cosine squared of x. Or how about I just play for a minute? Can I think of the sine of x times 1 over cosine of x times itself twice? Or can't I think of this as the sine of x over the cosine of x times 1 over cosine of x? Or can't I think of that as times another intimate relationship between a secant function and a tangent function? You're going to see this over and over again in mathematics. Now, I think I can use almost the identical proof to show you that to differentiate to cosecant of x, you get the negative cotangent of x times the cosecant of x. Please do not mistake what I intend. As of 15 seconds ago, I expect you guys to know these derivatives just like that. That's what I expect. And I derive them, maybe except for the second one. But its derivation will be first, just like the first one, or if you give me one more day, I will derive it using something called the chain rule, whatever the heck that is. All right. Let's see where you're at. Anybody? Anybody at all?
E of x.
E of the x times
Or
the
secant
derivative
squared
tangent
x.
of x plus,
E to the x tan x.
yeah, the tangent of x times the derivative of the x. Or maybe more concisely,
Secant squared x plus tan x.
do there. One over cosine of x?
Cosine of x.
Oh, so 1 plus cosine of x. So what's downstairs as is times
Cosine of x.
the derivative of the top minus the top times
Minus.
the derivative of the bottom, which is
Negative sine of x.
very nice. All over what's downstairs twice. Ah, if I can write it. But that gives me nothing more than 1 plus cosine squared of x plus sine squared of x. All over this. Are you happy? Are you happy?
No,
What do you mean no? Why not?
you didn't distribute the cosine x.
Yeah.
It should be cosine x plus.
Nabil, that was my mistake. I didn't mean to make that mistake. I'm sorry. I really did neglect that. That's my fault. Ah. Now are you happy?
Yes.
No.
Sounds good, but sounds very boring, right?
Thank you. Thank you.
Cancel out, and then you get 1 over 1 plus cosine.
Very nice. Did you guys catch all that?
So it equals 1?
Oh, excuse me.
Equals
1 over 1 plus cosine of x.
Or cosine x.
That's a sloppy one. Happy? Happy, happy, happy.
I'm
Yes.
a little confused on the second part of this, yeah, that one.
Where that came from?
Yeah.
You know, that's the root of the bottom. But the root of one is just 0. Plus the root of the second
Oh,
is just
okay,
negative
gotcha,
sign
gotcha.
x. So where are you guys on the happy scale? Are we at a 10? Good. 11. That's nice. That reminds me of some movie in the past in the 70s. What was that? Spinal Tap. Well, here's an embarrassing question. How many of you have ever heard of Spinal Tap?
Yes.
Oh, thank goodness.
You never seen Spinal Tap?
Never seen Spinal Tap. If you've never seen Spinal Tap, I'm sheltered.
It's like the funniest movie ever made. You have to watch it.
Yeah. Well,
It's educational. I
Think
mean,
of Ozzy Osbourne as best moment. And this goes from there.
showing it off. Yeah. You know, let's get
why don't you just make 10 louder? This one goes to 11.
Yeah, the argument is he's got a guitar amp, and it goes from 0 to 10 for the volume. And he's got a special one because he relabeled it as 0 to 11. And that makes his amp louder than everybody else's amp.
That is pretty funny. I gotta watch it now. Talk me into it.
Yeah, it's great.
Is he throwing a door?
What's he dropping the calculator
On
on?
top of my calculator in my hand.
Okay. Is he gonna jump?
Don't jump, dude.
Is that the question you had on your exam example?
Yeah, we were trying
What did I
to do
post?
this, and it was
You,
pretty
you had
difficult.
it in your, like you posted some of your old exams
Oh.
and the same question.
Oh, okay, yeah, it's a common, yeah, you're right, it is, yeah. Common scenario, sorry.